This is the first side meeting on network tokens. We had previous discussions at the TSV open area meeting and the application aware networking meeting. What we're going to do is have two talks. I will provide a high level overview and introduction, and then Frode will give the regulatory perspective around the traffic differentiation ideas, and we're going to leave room for discussion at the end. We will have time to take questions after each talk, and then time for discussion next step at the end. If you have a burning question, interrupt us or just write on the chat. With this, I'm going to start. So I'm a little bit of background. I'm one of the co-founders at a company called Selfie Networks. I've been involved in a lot of traffic differentiation integrations between application providers and network operators. This is joint work with Nick McKeown from Stanford, who worked with me to develop the original ideas. Frode Sorensen is from NCOM, and he was the tech lead for Europe's net neutrality regulatory framework. And Tom Herbert is from Intel and has done similar work with FAST that you might have seen. And we're sort of like discussing on how to merge these pieces of work together. I think collectively as a group, we've been thinking a lot about traffic differentiation and the interplay between app providers, network operators, and end users. And to summarize our learning so far is that the good thing is that traffic differentiation seems to be widely deployed worldwide, be it in zero rating, QoS, or firewall whitelists. It can improve user experience. It can help operators monetize their infrastructure. But one of the main challenges that we've seen, and others have commented in similar discussion this week, is that this is primarily done through traffic classification. And this comes with high implementation and operational overhead for everyone that is involved. And it's also in conflict with user privacy and encryption, particularly as transport protocols tend to encrypt their headers. The ugly part here, which is like a subtle topic, is that one of the biggest issues with traffic differentiation is that when we try to deploy such a service, it is unclear who controls what traffic gets differentiated. So is it the user, is it the network operator, the application provider, the DPI vendor, the operating system? We really don't have a good way to debate and answer this question. Just to translate these good, bad, and ugly with some real numbers, we've been involved in many zero rating integrations. So what we've seen is that more than 160 operators worldwide having publicly available zero rating programs, more than 1,000 applications participating in these programs, and more than 3 billion users having access to them. All detection, all sort of like zero rating is dependent on some sort of like application detection based on IP addresses or SNI domain names. And from like a subset of the integrations that we did, which were like around 100, what we've seen in terms of success rate for these integrations were 15%. And this goes back to the implementation overhead and security issues and privacy issues. The average onboarding time for the ones that succeeded was more than 9 months. And if we look at these numbers only in Europe, where there is a clear policy and regulation about like how zero rating should happen, which is in a way that is inclusive, categories based, and with straightforward onboarding, almost 90% of the programs, the zero rating programs, were non-compliant. And this goes a lot of back on like the challenges and the tussle between the different stakeholders here. One interesting thing beyond the good, the bad, and the ugly is that even though traffic differentiation is quite controversial, there seems to be common ground and consensus on specific use cases. So if you look at QoS as a use case for traffic differentiation, there seems to be consensus that a user-centric, application-agnostic, privacy-aware offering is consistent both with application providers and end users and net neutrality advocates and operators. If you look at zero rating for the regions and the areas that allows zero rating. A category-based, inclusive, and money-free agreement between application providers or operators also seems to be acceptable. And if you go to enterprise networks where like a firewall whitelist or like other type of services might be of interest, there doesn't seem to be a lot of interest and pushback. Like people are okay with any type of policy you want to have. And so this is our starting point. And by looking at that, hey, there is room to actually build traffic differentiation services that are well designed and they can like adhere to a policy.
Yeah, Giannis, I'm sorry. Can you just explain what you mean by category based?
Yeah, so the easiest example in Europe, if you're an operator, you can do you can zero rate music, but you cannot zero rate Spotify as a program. And so if you zero rate music, then you need to have a process that every music provider can come and participate in this program.
Got it. Thanks.
That's the main idea. And so we were, you know, the question that we posed to ourselves is, can we expose and access traffic differentiation services in a way that it's easy for operators to deploy and operate, it's easy for end users and application providers to access, is compliant with user privacy and net neutrality requirements based on the use case, and it works with modern infrastructure. And with this, I mean encrypted client hello messages, multi-cloud deployments, third-party APIs, and so on and so forth. And network token is the mechanism that we develop in order to meet these requirements. At a high level, network tokens enable explicit and secure coordination between end users and application providers on the one side and the network on the other side. They replace heuristics and DPI-based application signatures with a deterministic mechanism to drive this coordination. And one of the main insights that we developed as we were implementing and designing tokens is that essentially this looks more as an access management problem rather than a traffic classification problem. So the whole design has been heavily influenced by OAuth 2 workflows, access tokens, JSON web tokens, etc. Going a little bit more into the details, tokens carry simple claims. So for example, a token can be, hey, I'm Skype, or hey, I need low latency. They may be encrypted or signed based on the trust relationships and requirements between the different stakeholders. They have built-in provisions against replay and spoofing attacks. So we use things like expiration time, binding fields, and revocation to make sure that we are secure against replay and spoofing attacks. They can be represented in different formats, like JSON web token, CBOR web token, or custom formats. And lastly, tokens are inserted as extensions and attributes in existing protocols. We've been able to insert tokens in IPv6 extension headers, in TLS handshake extension, and in STAN attributes. And one of the things, you know, that we need to figure out is, okay, let's pick one to do some progress. And I think there are like trade-offs on where we do that. Now, one thing that I'd like to emphasize is that tokens are policy agnostic. So the policy, it's not dictated by the tokens as they are, but it's dictated by token distribution. So who can issue and who can access tokens, by the contents and the cryptographic functions that are applied to tokens, and finally by the end-to-end workflows that clarify how can somebody get a token, what permissions are needed, what credentials are needed, etc. You can have different types of tokens, but there are two of them that seem to fit in most use cases that we've encountered so far. One is what we call an application-specific token, which essentially says, hey, I'm this application, and you know, I can guarantee this. And the other one is that, hey, this is a user-driven application agnostic and privacy-aware token, where the main idea is that a user can get, can purchase or access a network service based on their relationship with the operator, and then they can decide which traffic can go through that service. As I said, the end-to-end workflow is very important. to make this applicable and to clarify like the policy that we're trying to implement. So let me show you a sample workflow to visualize how this looks like. Here we have, I'm going to show you a workflow around a user-centric application agnostic tokens. And we have three entities. One is the mobile operator that essentially exposes a premium network quality service through tokens. And the two boxes that you see here with the green annotations are the data plane and the control plane. We have an application provider. In this scenario is a video conferencing application that can benefit from the premium network quality service, and a user who is a subscriber both to the operator and the application provider. And the workflow that we envision goes as follows. It starts with the application asking user permission to access the premium network quality service. And this is, very similar to the way that an application can get access to a location or camera settings, etc. Once this application is being given, an agent in the client goes and fetches the premium quality token with a user's credential. And this agent can be at the operating system, can be a third-party agent sitting in the phone, or can be in the application itself. Once the tokens are given, the application developer gets access to them, and then they can attach these tokens to the flows of interest. And the idea is that it should be easy for the application developer. It's essentially an API, and they can define what flows need like the service in a fine granularity. Once this happens, the network can detect these tokens and provide the desired service. Two important things to mention here. One is that this is a sample workflow, and you can have different types of workflows defined around network tokens. And the second one is that a lot of the challenges that that we're thinking about, how to make sure that this is not abused, or how to give this to the user in a friendly way. I think we have all the mechanisms to do this with the existing stacks on client devices. So we have means to give permission either through the operating system or through something like Auth2. It's easy. People are familiar with this type of workflows, and application developers as well. One point is the design priorities and the trade-offs. When we sort of started designing tokens, we sort of thought that privacy and security and the trust relationships between the different entities are the hardest thing to get right. And so this is our first priority, and we believe that if we don't solve these, then it's pretty hard to do something beyond an academic exercise. So our goal is to deal with privacy, security, and trust relationships first. The second one is a path to adoption. So a lot of the challenges come on what are the incentives for somebody to do something, how you can have partially deployments in place. So that's the second thing that we consider. And the third one is implementation efficiency. There are some trade-off considerations that we are encountering as we are designing tokens and as we're implementing them. I will just briefly mention the main ones. One is, do we have a random token or do we have a structured token? I think if you do random tokens, you can have small tokens and easy processing of the data path. If you do structured tokens and start doing encryption, etc., it means that tokens get longer and they require more heavy processing on the network, which can be imply decrypting these tokens, etc. This has also impact on the state that you will need at the network. A random token will be very heavy on token state. Structured tokens, you will have to do them per flow most likely, and this means that you will have to you can eliminate all token state because tokens can be self-contained, but you will have per connection state. So I think one interconnected trade-off is random structured tokens versus per packet per flow. Another one is where to insert tokens. As you can imagine, there are strong opinions within IETF. One clear like demarcation is, do we put this into layer 3 and IPv6 in particular? Do we put it on transport, on like TLS or STAN, or like another option? A last trade-off is what is the role of the operating system on an implementation of network tokens. Obviously, the operating system can sort of like be a natural place to broker the permission and the trust between applications and users on the one side and the network on the other side. But there are ways to do this without the operating system, and this sort of brings up who brokers this relationship between the different entities. Current status, there is an internet draft that we push to data tracker. Right now, it contains everything from background and motivation to the overall architecture, generic tokens, specific tokens, insertion to protocols. We are well aware that we will have to break this into multiple documents. We just put it there in a single one so that people can easily read and provide feedback. We have a blueprint implementation that exposes a QoS service for 4G and 5G networks through user-centric tokens. We use these tokens to provide premium network quality for video conferencing calls that use WebRTC. And most of this code is in open source, and we do it in partnership with the Open Networking Foundation and their partners. And there is a mailing list at networktokens@ietf.org. There is a lot of related work, SPAD+, PAN, APN, FAST, SWORN. I think I'm catching up with the content and the learnings from these groups. One thing that I've seen both from what I've been reading and my discussion with individuals, both at IETF and outside, is that it's pretty important to prioritize and narrow down on a specific use case so that people get comfortable with the trust relationships and the privacy, etc., that are supported for this specific use case. So this is one of the things that we really want to prioritize. Focus on privacy, security, and trust relationship for this use case, engage with related groups, and we're actively working on an implementation and POC. And if you want to sort of like work with us on this, just contact me directly. I know that many of you might be in thinking about like cellular networks and how this relates to cellular networks. Both zero rating and 5G slicing in QoS are pretty hot topics in that community. One point that I'd like to make in terms of standardization, I think tokens, you can think of them as two different standardization efforts. One that happens at IETF is establishing an interface between applications and end users on the one side and the network on the other side, and I think this is better fit for IETF. The 3GPP has to do more with how do network tokens fit in the 3GPP architecture. One of the good things is that most functionality fits under the existing 3GPP interfaces for traffic detection function and DPI. And if we could add tokens to packet filters and traffic flow templates as standard fields, this would help a lot. So we haven't done any work with 3GPP yet. If you're interested on taking part on this, let me know. That's all. What I want to do is close with a question, which is, what is the use case that you're interested in? I think this is like, maybe the most important next step that we have to consider. And so what service are you mostly interested in? Is it QoS, zero rating, firewall, in-network telemetry, something else? What type of token consensus seems to be the best fit for your use case? Do you agree with the consensus statements? And what insertion point do you see as more viable? And with that, I'm just gonna open it up to questions to everyone. I think, Liz and Bing, you have a question?
Yeah. Can you hear me?
Yes, I can.
Okay, I have much interest in your implementation. Can you go to that slide? You mentioned that you implement some of these the use cases in the own app.
Yes.
So I want to know, because I know that this is just the data plane, or you also implement some of this the client and the controller. This is the interworking.
Yes, so the implementation that we have right now has the following components. It has like a data plane that can process tokens. It has a client phone functionality that can sort of like get the tokens and insert the tokens. And it has some control plane functionality that on the one side orchestrates, talks with the data plane to make sure that the tokens are there and can be verified, and also distributes the tokens to the endpoint.
Okay, so you take use of the P4 and the honors.
So right now we are using this goes like a little bit too much in the details. Right now we're using the BESS-based data plane that ONF has, which is on the UPF EPC, and we're looking to do an implementation on top of P4.
Okay, so I want to know if you have some this the data analysis. If we do this work, so will this have much effect on the forwarding performance?
So far from what we've seen, no.
Okay.
Okay, happy to take this offline. I think it goes like a lot into the details of this specific implementation, but happy to take this offline.
Okay.
Any other question?
So this is Daniel, DKG, Daniel Kahn Gilmore from the ACLU. I'm just, I apologize for being a bit of a tourist here. This is the first that I'm really grappling with the questions, although it's not the first because I was involved in the SPUD Plus discussion and all of that. I'm curious about, and I apologize, I'm gonna need to run in a second because I'm double booked, but I'm curious to know what the perspective of the Network Tokens project is on the fact that using the internet seems to require typically multiple networks, and how you, I mean, as you rightly identified, trust relationships is a big part of this work.
Yep.
And it's not like there's one network between me and the other endpoint that I'm talking to. There are potentially, I don't know how many there are.
Yeah.
What is there a frame that the Network Tokens project sees for dealing with this, or is it like we're just talking to the local network?
So I think a couple of points to think about this. The first one is that there are several use cases where you just need one network for the service. So if you think about zero rating, there is only one network that does the charging. If you think about firewalls, there is only one network that does the policy. So in these scenarios, you want one network. What you want from the other network is not to ruin you, which means like do not drop or do not mangle the token. Now in the use, also if you think even about low latency, if you combine this with edge nodes that are like inside the operator's network, then even like a QoS thing could be part of one network.
But as the end user, I have no way of distinguishing between those things, right? Even as a technically sophisticated end user, it can be very difficult to distinguish.
Yes, I mean, like I think the one thing that we've seen happening in practice is that like application developers on mobile phones, they can see what is the operator of the what is the SIM card that this phone is there, and they can adjust like their behavior based on this. And I think like as a user, you don't do this on a like very short timeline. It's more of like, yes, I want my calls to have like high quality, and then there can be some manual on and off. The other way to think about this is that I think having tokens that can support multiple networks is an open topic. We think there are like a few options to do them. One would be to have a token that can be interpreted by multiple networks, or have multiple tokens within a flow, or have a token that can have multiple recipients using the capabilities that JSON Web Tokens have with different keys for each recipient, etc. And so I agree with you that it's like, it's an important question to ask. We're like more focusing on solving this for one network right now, for like, the network, the network that is likely closer to the end user. And
but my question is, so I agree with you that the multiple network thing is even more complicated mess in terms of trust relationships and user experience than single relationships and single network. But my point, I guess, is that I don't understand how the user is even going to be able to distinguish between the networks. You said that firewall was an example of a single network case, but I'm often behind multiple firewalls.
So look at it this way. So the whole premise here is that the application requests service from the network. So there's some agent in the network. Application creates a request saying I need low latency and these parameters. Here's the destination. Gives that to the agent in the network. The agent in the network determines whether or not that service profile can be manifested. So if it can,
how does the end user know which network it's talking to, right? My traffic flows
the end
across
user
multiple
doesn't
networks.
need to. All the end user really needs to say is what the destination is. So the end user, this all needs to be transparent to the end user. The only thing the end user gets, the end user requests some service and it gets a reply if that service can be met. So we want to abstract out all the details and make that a network specific thing.
So it sounds to me like the answer is we are building techniques for anyone in the network to attack a given connection or change a given connection. And the user will have no idea who is doing those things. This is not a recipe for a good trust model.
But I think the user is asking its local network, and that's where the trust relationship is.
Okay, you didn't say local network earlier, and how am I supposed to know that it's coming from the local network?
Because this is an out-of-band thing. The user, this is configured. There's a agent running on each client that knows how to contact the local network. That creates a trusted relationship. So the local network can provide trusted tokens back to the user.
But many clients have are connected to multiple networks today, and the user doesn't necessarily know which network they're connected to. When you use Wi-Fi, you have no idea what network you're connected to.
But again, it's not so much the user that is, it's the application. Presumably this would be front-ended by an application library, and the library could determine based on the destination which network is in use. And if it's possible that the same flow could use multiple networks, then maybe the application creates tokens for multiple networks and then applies the correct token per network. I mean, it's an interesting point because this does convolute things.
So Daniel, one sort of like way to think about this is that if we think of a practical example, right? As a user, the one typical way we're thinking about this is as a user, I'm subscribed to a low latency path from my operator and a best effort path to my operator, and I'm telling that, hey, my game, I want my game to access the low latency path. So that's the decision that I'm making as a user. From that point on, the game developer can sort of like identify which network to use a token for, which flows to use a token for, etc. So I think the low-level details of like, which flows on which network, etc., can be dynamically taken care of by the application developer or the operating system. What the user gives is the high-level permission that I purchased this service, I'm willing to pay, and I want this application to get this service.
I would like to know,
Sorry,
how...
I think we are gonna need to pause here for a moment and give time for Frode to talk on the regulatory side of things, and then we'll have another 20 minutes for discussions. So if you can hold your question for afterwards, that would be great. Okay. Frode, can you take over the screen?
Do that.
There it is. I will give a short presentation about regulatory considerations, trying to explain why this network tokens initiative is interesting for regulators. A brief introduction about the regulatory considerations. In general, it's important to realize that the regulations are not provided by the regulators. The regulations are provided by the lawmakers, and the role of the regulators is to supervise the market based on this regulation. The general goal of the regulation is typically the social benefit of the services, including the preservation of the internet innovation. At the same time, it's important to avoid any limitations to technology development. A quick recap of the European perspective. Coming from a European country, I will present and discuss based on the regulation we have in Europe, and the Open Internet regulation consists of two pieces of text. It's the regulation, the law itself, and in addition to that, the regulatory organization called BEREC has developed guidelines describing more details about how to interpret the regulation. In addition to focus on open internet, there is also, as many of you know already, focus on privacy in Europe. We have a general regulation of privacy, and also in the open internet regulation there is specific statements about privacy that has to be taken into account. And here I have provided references in case you want to go into the details of these texts. Turning over to open internet considerations, it's important to realize that also under the open internet regulation, there is a possibility to do quality of service differentiation. Equal treatment does not mean that there is an identical treatment to any traffic. An easy example to understand is that in fixed access networks, you can have different speeds on the access, and this can also be provided in mobile networks, even though this is not usual in all countries, but in a few European countries, this is already available. But it could also be differentiation based on other quality of service parameters than speed, for example, latency. The only requirement that is in addition to general net neutrality is that this differentiation has to be application agnostic. And the rest of my presentation will focus on how to understand the term application agnostic. An easy example is that you can do differentiation between different subscriptions, which means that when you are a particular user, all of your applications can run on the quality of service level of your own subscription. Then there is also this discussion about whether it's possible to differentiate between different applications within a single subscription. And this is possible to do under the European regulation, and this is also similar to the net neutrality and quality of service paper from Barbara von Scherwick that some of you may know already. How can one understand that differentiation within one subscription is in line with the open internet regulation? The European framework, as understood by BEREC, provided some clarifications to this in the revision this year, which was published a month ago. And the way we understand application agnostic is that any application can run on any quality of service level. It doesn't mean that all applications has to run on the same level, but any application can choose which quality of service level it will run on, in case you have several quality of service levels available. This means that this should not be predefined by the network, and it could be selected by the end user. And the end user will typically do this through the application, as has been discussed already actually in presentations earlier today. Practical implementation of this could be two different ways of doing it. It could either be configurable in the application, typically as a telephony application, a speech transfer over the internet, where the end user configures this application to run on a higher quality of service level than the ordinary traffic he sends. Alternatively, it could be selectable for each session, where the end user can choose whether to use ordinary quality or a higher quality level when he sends his traffic. A few words about zero rating, since zero rating is also mentioned in the presentation of Giannis and also in the network token internet draft. Zero rating is also considered under the European Open Internet Regulation, and it's further clarified by the BEREC guidelines published this year. When zero rating is assessed under the regulatory framework, it's done based on several different criteria. There is not a clear-cut answer to whether zero rating is allowed or not in a national market, but it has to be assessed based on different criteria. And one of the most important criteria is whether the program is open. And the definition of open means that if a provider, if an internet service provider has a zero rating program, it has to be open to any applications within the same category. For example, if music streaming is available as a zero rating application, it should be applicable to all providers of music streaming, whereby all music streaming applications are zero rated. This is also clarified in the BEREC guidelines, where it says clearly that open zero rating programs are less likely to restrict end users' choice or undermine innovation on the internet than zero rating of a single application or programs that are not open. So this is just a brief introduction. Most of the discussion today has been on quality of service related aspects, and there was also a question in the chat which I may answer depending on how Giannis wants to run the meeting.
Yeah, please go ahead.
Additional questions as well as you like. Thank
you.
So
is there a specific question?
Yeah, there was a question about charging of quality of service. I turn back to the previous slide, and as it says here, you can run applications on different quality of service levels. And I guess the question was related to whether there is an incentive to provide this kind of internet service access from a service provider. And probably that would only be interesting in case of charging of the application. And the BEREC view on this is that it's possible to do charging of the local user, which means if I, as a subscriber, select a higher quality of service level, that can be charged to my side of the communication. As it says on this slide, this quality of service level should not be predetermined by the network or the network operator, which means that it cannot be charged to the application provider, which is at the other side of the communication channel. It can only be charged to me locally as an end user. I hope that answers the question, but I can take follow-up.
I think Tom Hill has a question, and then Joy, I don't know whether you answered the questions in your chat, but Tom Hill, Tom, is your question answered, or there is another one?
Possibly. If I may just float the potential loophole, and you may shoot me down here. assuming a application developer, provider, vendor produces an application, a game, for example, it wants low latency, and upon installation, it sends a message to the user and says, this will require a setting of a premium service. It doesn't work without it. Do you still want to install it? And if they click yes to install it, is that user choice? And if so, could this be a case of net neutrality exemption sort of by the back door? I mean, I'm a bit concerned that if we give more power to this, that applications will find a way of taking advantage of it.
I would say the same question is like with an application that has access to your location or to your camera or to,
But we're not talking about location or cameras. We're talking specifically about net neutrality. So
yes, I would say that access to my camera has like bigger risk for me to be careful about this with, than like, the network side. So I think
my question really was, Yanis, it was really to the speaker, because I'm asking about the regulation and how the regulation will see this.
I can give a quick answer. The regulation itself is not that detailed, so it doesn't answer your question explicitly. But this aspect you mentioned has been discussed among regulators, and I think the general view is that this should be configurable by the end user, but it should also have a default configuration where it is not prioritized and not charged. So it has as a default configuration where all traffic is sent on the same quality of service level. I think that's the general view, and I think that should, to a large extent, solve the concern you express.
It poses another question, but I'll yield my time. Thank you.
Okay, thanks.
So Joy, do you still have a question, or are you covered by the chat?
Thank you. I did ask them in the chat.
Okay.
I think I'm good for now.
So Lars goes next.
Hey, so I have a slightly different question that hasn't been discussed so much. And so we've done INTSERV, like, integrated services a long time ago. And we've done NSYS, which was a signaling protocol to replace RCP, which also had a sort of, both of these things have this concept that you describe what a flow expects from the network in something called a flow spec, right? Which has a lot of the same things that you guys talk about, like jitter, delay, maximum bandwidth, and so on. One of the problems we've found with these things in the past is that almost no application can fill out a flow spec, right? If you think about the Zoom call that we're on, right, it probably has like 10 or 20 or 30 different flows. What would an application writer, put in that flow spec so that it could be, expressed to the network? All of these things work well with best effort, right? So it's very difficult to actually write down for a given application, what do you expect from the network for this particular flow, right? It's typically you want, the lowest delay, or you want the fastest throughput, and there's not really anything else that you might want to express here that makes any sense in general. So the problem we had in the past is that people wrote these insane specifications that allowed you to express very, very complicated flow specs that in reality then nobody could use.
Yeah.
So that is one problem, and I wonder if you've thought about this, right? Because you have that problem.
Yes. So I think we don't have any concept of a flow spec, right? I think the way that we separate the two is that the network says, hey, I have this service, and it's up to the network operator.
But what is this? How does the network express what this service offers?
Yeah. So I think these services, I have a premium network quality service, and somebody needs to go and understand what the premium network quality service means for this operator and decides whether they want to use it or not. I think we want to be very, very careful to leave the control of the network to the operator and then enable the endpoints to use these services. If they don't like the services, they shouldn't be use them and shouldn't pay for them. But like in one specific example, on the video conferencing stuff, like a specific use case. First of all, like the network already has cellular networks, as an example. They already have voice over LT that uses a dedicated bearer to provide specific QoS characteristics for voice calls. You can also combine these with a provision path that doesn't have buffer bloat, etc., so that it's better suited for like low latency environments.
But that particular service that you talk about, right, is actually not accessible for internet protocols.
Yes. So voice over LT is IP, right?
So the 3GPP voice over IP runs over IP, but the bearer is set up separately, right? So it's actually not something that Zoom can take advantage of, for example.
So that's exactly what we're trying.
I understand that the operators would love to have these sort of different offers that are sort of pay to play, right? But again, the problem that you described earlier, right? That the applications don't have to specify the expectations. The operators will sort of say, here's what these different levels mean. It's the same problem, just in reverse, right? An application still needs to understand what these different service levels offer and then decide what it wants to use, which is kind of difficult.
So I think like in that specific example that you mentioned, this is the exact motivation that we have, that, hey, the network can already do something, and this is like on a bearer. And like we want to provide a mechanism for this, like, thing that it's vertically integrated and requires awareness from the operating system, the application driver, the network, about everything. We want to disaggregate this and to open this up. And frankly, you can do this with the existing like 3GPP. So we are doing this now with like an LTE network using dedicated bearers, and we can pass traffic that is not voice over IP.
So in some sense boils down to so if you're in a hotel, right, you often can get the free Wi-Fi and then you get the premium Wi-Fi. And there's some description of what the difference is, right? I can often not figure out if the premium is worth it, right? And so how, and the network specific characteristics that are expressed in this, you have this much bandwidth or this much down, it's pretty meaningless when it comes to application QoE. And so a user cannot, like, yes, you can always click the, I want to pay more. But the question is, would not paying be any worse?
That's the challenge for operators. That's the challenge for operators to come and design a service that it's meaningful and it's value added for the users. If they can do it, they will succeed, right? And we're not saying, this is out of scope for this work. Here we're saying, let's assume that an operator has a service that can add value to the end users and the applications. How can we expose this? I agree with you that in many cases, this might not be worth it and people might not use it. And I think we are saying that, hey, there is this discussion, and in some cases it worth it and people buy the plan. So people buy 0 rating plans quite a lot. And so if the operators can get up to the challenge and offer a QoS service that it's meaningful for users, and this is not like a hotel relationship that it's one day, this is like a long-term relationship where you can build credibility about like a service, then what we want to do is like expose and access this service in a proper way that respects privacy and net neutrality, etc. You're right that the service itself might not worth it. And if the service doesn't worth it, then no reason to expose it. But we believe that there is a good chance that the services are going to be interesting enough for people to use them.
I'll let somebody else speak. I've said my piece for a while.
Sorry, I put my comment in chat, but my understanding is that providers already do this today in the sense that they're doing DPI and they're determining which application is sent, and then they're using that information to put it into different services. Am I mistaken?
Any operator that wants to comment here?
This is Magnus Westlund. not an operator, but still. There's some, I mean, that's also just based on where the traffic is going. I think there's a lot of classifications actually is based on saying, no, you know that your service is going from the client to these particular servers. And that's what's used for the flow classification.
Yeah, but that's more than just routing. This is actually looking at and trying to determine what the application is in order to differentiate what they're doing based on the application. So it's hard to see this different, but obviously the thing that the troublesome about that is this is per application, not some abstraction of what the application needs. So I imagine for net neutrality, this is probably worse.
Well, I mean, if you're going to zero rate, then you know that you're going to zero rate, let's say, YouTube, HBO, and a few others in your country, and you know where their service is because that's the information you ask the provider saying, okay, where is your traffic going to come from? Tell us that, and then you get zero rated if the traffic comes over from that source address. And that's your classification. And then you maybe verify that
there's a big difference between prioritizing for YouTube versus prioritizing for high bandwidth video services. And it may end up being the same thing, but obviously the marketing for that is very different, right?
Okay, I think we are sort of like reaching to the end of the hour. One sort of like thing, that we are like looking to do is continue this work. As I said, we're very, very interested on a specific use case with very specific characteristics, because I think, one argument is valid for zero rating and not valid for QoS and vice versa. So I think one thing we want to do is like pick a very specific use case. If you have like use cases, either like, talk now or like, talk to the mailing list or contact us directly, very, very interested to understand like, the use case and see how we can sort of like where to focus, etc. The other thing, and Magnus might sort of like, comment also here, I think we're looking at how to proceed in next steps. The plan is to hold another side meeting in the next IETF for sure, and hopefully have enough consensus to go for above on 110. Is there interest for this from people here? If you can plus one to keep participating into this discussion. If you can plus one on the chat. Magnus, any specific comments from your side as a transport area director?
So
sorry,
I mean,
sorry for putting you on the spot. Just
well,
like...
so no, but that, I mean, from a high level, I think you gotten feedback, and I think you need to tease apart these different problems and trying to drill down on saying, okay, what can you actually, when it comes to the security model, what can you say, what does it imply, and what's the, I mean, there's all these aspects of this, it's that needs to be teased apart, I think, and clarified, and saying, okay, this we can do, this we know how to do, this is what's hard, this is what's needed, and trying to arrive at saying what's actually needed for realizing this and what's the challenges. And I think that's where you need to improve your drafts, etc., also to better explain this and so people can read and understand those aspects. But yeah, so.
Any other comments by anyone? I think we're reaching at the end. Have a couple more minutes.
Zhengbin, in the queue, yes. Is that okay? In fact, we have a fruitful discussion in the APN side meeting, because now if we collect all the work together, it will a very huge work, mixing the int area and the transport area, application area, and the and also the routing area. So from my point of view, so I think this work is very difficult to be done in IETF. So from my point of view, at least for me, I think that's at least we can distinguish the scope. The first one, we focus on the network layer. So this is maybe that's the differentiate how to get the application information, but it's just encapsulate in the network layer. And another scope for this work, I think this has much relation with the application area or the transport area. That means the end-to-end negotiation, and also is to apply for the application specific information such as the network token. So I think this maybe we can have some distinguishing work, but the challenge for the transport layer work and the application layer work, I'm a little worried about the existing the past work of the such as the SPAD and the PLUS or the PAN-RG. So I means the possible way is that we can focus on some of the specific use case. I agree with this very much. But we think, I think that is better we can identify some of these use cases, make it try to convince of the people about to agree with these use cases. So then we can work on this one and to provide the possible solution based on the network token. That's my point.
Okay. Okay. I think the comments also on sort of like considering like how we can combine this work with APN is sort of very, very relevant. So I think, you know, over the next between now and the next IETF meeting, does the APN community looking to have a BOF on 109 or further down the road?
In fact, I introduced this work. In fact, the IETF 107, we try to apply for the BOF, but it's not accepted. Because of the IETF leadership remind us of the existing the SPAD and the PLUS work.
Okay.
So one question: did we have a mailing list for APN?
Yeah, we not.
Okay, so first step to getting the BOF, you need to have the mailing list, and then we need to get the traffic on the mailing list, and then we can do probably a non-working group forming BOF seems reasonable for, I don't know, maybe 109, the ADs can probably specify that.
Okay, everyone, I think we just ran out of time. Thank you very much for contributing here. Just as a reminder, there is a mailing list around network tokens, there's a website. Please contribute to the discussion. I think it's important to show that there is interest and there is traction to keep things going. If you have like any follow-up questions, happy to talk to you offline as well. Thank you very, very much. We will video and the minutes from the meeting on the wiki page for the meeting.
Okay.
Okay.
Thank you, Yanis.
Bye.
Bye.
Thank you. Bye.
Bye. Thanks.